Okay, let's continue working on question number 10. It's very similar to question number 9 that we worked already, but I still go over. So first question, what do we need to do? Plot the data. All right. We already know how to plot the data. StatCrunch. All right. So that's gonna be 0. Let me see. 1, 2, 3, 4, 5, 6, 7, 8. As I mentioned in the previous video, but I don't mind to repeat it now. The reason I'm doing this because not to work with big numbers, 1997, 1998, this way we're gonna deal with 8, 9, 10, 11, 12, so it's gonna be easier. Plus your plot is also delimited like that. 15, 16, 17, 18, 19. Yes, is this what we have? Let me see. 86 minus 9. Yes. All right. So let me, okay, better brightness, going graph. Okay, chart, column. So we are using GDP because dependable value, which is Y, is GDP. And in which format is given our plot? It looks like a scatter plot, so I'm choosing points. Oops. Okay. And compute. So this is what we have. And if we look at the answer, yeah, here it is. We are getting this point. Let me zoom it. This point. And back to our result. Here it is. All right. Okay, what is next? Compute linear trend. All right, linear trend. We go stat, regression, and simple. This is year, this is GDP, and compute. And we are getting a result 2256.8 plus 362, blah, blah, blah. Here. Okay, and axis represent year. Okay, so we got this one also. Plot the trend line. Okay, so let me go back again. Regression, simple linear. This is year, this is GDP. Compute, and second page is going to be our trend line, which is linear regression. Okay. What is our next question? C. What are your forecasts? Let me see. Let me move up so you can see better. What are your forecasts for 2006? Okay. And 2007. So let me see. So 2006, we're gonna know how many years. 2006 minus what do we have? 1986 we got 20. Here is 1986. Yes? Original 1986. So we get 20 years. So what I'm going to do, I'm going to plug into this equation. So instead of x, I'm plugging 20. Let me see. So first I'm going to multiply 362.6. It's my, here it is. Let me zoom it. 362.6 times 20, right? I put equal sign, so make sure I got this multiplication. And then plus, what do we have? 2,256. 2,256 point, what is it? 0.8. And I got 9,508. So we got it. Here it is. Right? And the same way for 2007. So you can do it. So if it's 20, then it's going to be 21. Right? So three 62.6 times 21 equal this much, and then plus 2,256.8, and we are getting 9,870. Here it is. $9,870. Okay, so for practically for 2006 we got 9,500 and something. For 2007 we have 9,800. So what conclusion you reach concerning the trend? Well, it's there is an upward, and or the other word is downward, and obviously it's gonna be upward, right, from 2006 to 2007, correct? And trend is going up since 1986. Why? Because see here we have linear equation. So let me move it here so you can see here. Linear equation. Okay, it keep growing. All right, moving to question number 11. So let's see what we have. We need to plot and on the plot we have from here, we have from 0 to 10, which means we need to go from let me see. Yeah, it's easier to put 0. Zero, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we need to plot here, assign the coded value 0 for the year. Yeah, we assign from 0 and choose the correct graph below. So okay, we are going to get something like this, exponential somewhat, or linear, we'll see it by trend. So let me see, chart column, solar power. It's supposed to be scatter plot. point. Okay, yeah, indeed, we are getting same graph here. Okay, this is the same plot. What is next question? Compute linear trend forecasting equation. Well, let's do it. We can do it. It's gonna be stat, regression simple, year, solar, and we are clicking compute. And what did we get? A, B, here it is. Negative, oh, we got -7. Is this the right one? Let me see, -11, 28, 67. No, it's not the same. Let me double check again the data, if I put it correct. Oh, 250, the last one. Why I have 248? Where from? 7. Wait a minute, this is different one. Hold on, let me copy this one. Clear, let me see, Control X. No. Control X. Okay, I'm going to, maybe it's from the old one, I didn't close it. I don't know. We'll find out. Here it is. So Control V, 0, 1, 2, 3, and here I'll just put 4. And here is I put 8. Okay, let's go now. Simple regression, year, solar, okay, compute. We need to get -11, right? Yes, -11 plus 28, 67, oh, yeah, -11 plus 28, 67, X. Okay, we got it. So we need to draw the graph. And with trend, we have it here. I'm going to second page here. And there we go. 2 points above the line, everything else is down the line. All right, we got it. And then next question, quadratic trend. Quadratic trend, we're gonna choose polynomial regression. All right, here, solar, compute, and we got quadratic. So 20, 136, here it is, 0.93 plus 3.47. Okay, we got that one, and we are clicking next page to see the graph, and it's going to be, let me see, this one. Here it is. So this is C. Here is the last one. All right. And here is the graph to compare. Look here. Compare to each other, right? Okay, we got it. One, it's above, here it is, it's a little bit above, and I can zoom it. Here, one is above and one is right on the line. All right, so we got that one. Closing. What is next question? Compute exponential forecast. exponential forecast. So and the exponential forecast when they are graphing, where is it? Oh, here it is. And when they are graphing, it also coded the year from 0 to 10. Then I'm going to copy this. Okay. Hold on, highlighting. And then I can do Control X, cut it off, and then go to Excel spreadsheet. Control V. Okay, we got it. So let me double click. Let me see. I could type here practically. Instead of A, hold on, let me see, I can type year. No, okay, I'll do that. There is a way to change the title, I don't remember now. Simple way, we'll figure out later. So for now, what I'm doing, highlighting and insert. Hold on, let me bring down this so you can see. Here, I clicked on insert and choosing scatter plot. This one, moving here. Okay, and we need to have it with trend. Yes. So I'm going to click and add trend. It's exponential, and I want display equation on the chart. Let me move up so you can see. Here, display equation on the chart, and close it. So I'm going to highlight on this, zoom it all the way till 20. Okay, so we can see, and it's gonna be 1965 here, 19650, and times, because where E next to it, it's E, that means multiplication, and raise e to power 03332. I already told you, right? But let me repeat. So you are punching, you are turning your calculator on iPhone, so it become the scientific calculator, typing 0.3332 and click the button e to power x, and you should get 1.395 times xe. It's jumped up, looks like power, but it's not, it's multiplication, and you will get this expression. Okay, accordingly, here is the correct answer here. Let me move it here so you can see. Okay, and this is what we have, same thing. All right, so we got this one also done. What else we have? Linear trend, the trend. So for 2009, since we are given 2008, in so 2009, what we're gonna do, 2009 minus 2000. If you ask in previous problems, we just took the last value of the table. Here we can't because we didn't calculate the average, remember? So here we're gonna follow our equation, which is negative 11 yeah, negative 11 plus 28.67, because this is a linear equation trend. Let me move this away, but I don't close because we are going to do multiplication. Actually, I don't need it. I'll do multiplication on second page. That's okay. All right. Bringing here. So 2009, because it's starting from 2009 minus 2000, it's going to be 9. So if you take it, okay, let me do it. Calculator. So what do I have? Let me clear it completely. So I have 28.67. 28.67 times 9, right? Oops. 7 times 9. And plus, how much do we have? Negative 11. Oh, okay. Actually, I have to do minus 11. And it's going to be equal 247.03. Let's go back and see here. 247.0. Next, since again for 2009, difference between 2000 and 2009 is 9 years, plugging to quadratic trend. Our quadratic trend is this one. Plugging here, don't forget here you have to square it. 9 squared is going to be 81. Here is just 1. You solve it and you should get 310.6. And for exponential trend, you are going to plug here. Again, don't forget, this is not exponent, this is multiplication. So you have to multiply, not raise to power. So 1.395 times 9, because of, again, for 2009, and then multiply by 19.650, which should give you 394.2. If any of you don't get the answer, just contact me, text me, I will help you. And then for 2010, for 2009 was 9 years, 10 it's going to be 10 years. You are repeating same thing and getting these numbers. And we are done for number 11. Moving to number 12. Let me see if it's same thing. Plot the data, it's identical thing. And then trend forecasting, plot trend line. We already know. Here is a trend line, so we can do it again. And then quadratic forecasting trend, we already know. Exponential, you already know. Okay. So since we already, here I opened the answer and we already know the equation, let me see what it says. Which model is the most appropriate? Well, let's see how we're gonna know. We're gonna know comparing the graph which one is going to stay close to the trend line. Here it is C. This is hold on. This is exponential one, right? Yeah, exponential one. This is a quadratic one. Here it is. And this is linear. Where is linear? Hold on. Oh, linear is A. Here it is. Okay. So this one, A here, it's a little bit up. Scrolling down, B quadratic. I would say quadratic is more precise, sitting online, everything. And the exponential one, this line is a little bit above of the trend. Here is everything sitting line. So I would say this quadratic trend is going to be the best fit. Oh, quadratic model is the most appropriate. Okay, we got that one too. And then using the most appropriate forecast model, which is going to be quadratic, find out for the year using the most appropriate model, forecast the tons of electronic items recycled in 2008. So 2008 minus 1999, you're gonna get 9. That's why it says 9 here. It's already helping you. So all you're gonna do, plug to this model 9 quadratic trend. Plug 9, it's gonna be 81. Here it's gonna be 9, and then add them up, and you should get 256.7. And that is number 12. Moving to number 13. Okay. What question do we have here? In forecasting daily time series data, how many dummy variables are needed to count the seasonal component day of the week? Seasonal component day of the week. So how many days it's gonna be? It says obviously 6, right? Without Sunday, because Sunday we count as relaxing. It's Saturday, not always. So Monday, hold on, let me go. Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Yes, 6 days. Okay. Question number 14. Okay, number 14. What do we have? In let me move here. In a forecasting time series over the 5-year period from the first quarter 2005 through the fourth quarter of 2009, the exponential trend forecasting equation is given below, where quarter 0 is the first quarter of 2005. Okay, so what is the fitted value of the series in the fourth quarter 2008? So every year we have 4 quarters, right? So started from 2005. So 2005 is 1, 2006 is 2, 2007 is 3, 2008 is 4. So 4 years, 4 quarter per year. 4 times 4 is 16, and because it's asking to the count quarter from 0, so I'm going to do 16 minus 1, because if you count from 0, instead of 16, it's going to come 15. Okay, so it's going to be our x. 1 second, let me open here MS Word. Our x is going to be equal 15. Okay, let's make it small so we can see what's happening here. All right, x is equal 15. Now let's look into quarter 1, quarter 2, quarter 3. Quarter 1 can be all 3 quarters can be either 1 or 0. If it will ask for quarter 1, Q1, then you put 1. If it's not asking for quarter 1, it's going to be 0. Same thing regarding quarter 2 and quarter 3. Since in our case it's asking fourth quarter, so all these 3 quarters are going to be 0, which means negative 0 3 times 0 will be 0, 0 15 times 0, and 0.1 times 0. All we're gonna have 3.0. Let me type in. So if I type log y, let's consider it's a hat, okay, because I can't type hat here now, is equal, what do we have? 3.0 right here, 3.0, 3.0 plus It was how much? 0.1. Yes, 0.1 times 15, right? We counted 15 quarters. 0.1 times 15. If you wonder why I'm typing, you will see in a minute. So it's gonna be, let me move it here, equal sign, 3 plus 1.5, right? 0.1 times 15, 1.5, which is going to be 4.5. 4.5. Now we get log y hat log y is equal 4.5. It's a logarithm. Log, when we don't have here any base, that means you have here base 10. Okay, so from here logarithm y is going to be equal 10 raised to power, this way, this is how we put power, 4.5. How you gonna do it on your calculator? I'll show you how to do it in on iPhone, and you will be able to do it on any computer, any calculator. So turn in horizontal position your calculator in your iPhone, and then you are going to type 10, and then push the button x to power y, and this exponent 4.5. In my case, I got 31,622, and which is gonna be, here it is with some decimals. Okay, this way. Here it is, 31,622.78. Okay, that's the answer. Now, next question, it's asking for first quarter, same thing, first quarter of 2008. Okay, let's see, 2005. Okay, so 2005, 6, 7, right? It's gonna be how many? 3 times 4, it's gonna be 12, and because it's a first quarter, so it's gonna be 3 year, right? 5, 6, 7. So it's gonna be 12, and because we code it from the from 0, so it's gonna be, instead of 12, x is gonna be equal 11, right? And this now here it's gonna be interesting. So we are going to get 3.0 plus 0.1 times, in this case it's gonna be 11, and then plus, because it's asking first quarter, so our Q1 is gonna be 1, or minus, in this case, minus 0.3. Okay, minus 0.3 times 1. The rest is gonna be 0. So what do we get? So we are getting, I'm doing this piece first, 0.1 times 11, it's going to be 1.1, and then I'm doing plus 3, I'm getting 4.1, and then subtracting 0.3, 0.3, and I'm getting 3.8. Okay, 3.8. So this is gonna be equal 3.8. So this is here gonna be 3.8, and this time we're gonna raise it to 10 to power 3.8. So let me do it. Scientific calculator, 10 pushing button x to power y, and then 3.8. And I'm getting 6,309. Let me see if I get the same thing. No, I got 7 here is 7,942. Oh, I didn't count the first quarter itself. So practically 2005, 6, 7, it's gonna be 12 quarters, and first quarter 2008, 13 quarters. And because we're coding from 0, it's gonna be minus less 1, it's gonna be back 12. So, okay. 12. This one is gonna be, instead of 1, it's gonna be 12. And we're gonna get it here. So what are we gonna get? 1.2 plus 3. I'm getting 4.2 and minus 0.3 and get 3.9. This is equal, not minus. Hold on. 3.9. So I am raising here to power 3.9. All right. So let me see. 10 raised to power 3.9. And I got 7,900 something. Yes, 943. We got it. So did you understand what was a mistake? I didn't count first quarter of 2008. Look, fourth quarter in 2005, fourth quarter 2006, fourth quarter in 2007. So three years times 4 is 12. Plus first quarter 2008, it will be 13. But because we're going to count from 0 instead of 13, I put 12. All right, and you get the answer. Okay, the same way you're going to do for the fourth quarter of 2009. So here we have 2005 is 1, 6, 7, 8, 9. 5 years, fourth quarter. 2005 to 2009, 5 years. 5 times 4, 20, and minus 1, because we are coded from 0, it's going to be 19. So because it's a 4 quarters, all Q1, Q2, Q3 is going to be 0. All you're going to do, 3 plus 0.1 times 19, and then take the logarithm, so y will be equal 10 to power whatever you get here. And the same way, it's the first quarter. Let me do first quarter, 2010. If 2009, it was 5 years, which is 20 quarters. So plus 1, 2010, 21 quarters. But because counting from 0, it's going to be 20. Let me do that one. So it's going to be, let me see. 20 times the 0.1, it's going to be 2, plus 3, it's going to be 5. And because we are counting first quarter, then this Q1, we're going to put 1, which means we do need to do minus 0.3, minus 0.3, and I got 4.7. 4.7. And at the end, I need to take 10 raised to power 4.7, and I'm getting 50,000. Where is it? 50,118 point blah, blah, blah. I got the answer. Okay? Okie dokie. Moving to question 15. It's, no, we are not going to do this. It's too much logarithm. Hold on. Plot the data. So blah, 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 blah. Let me see if StatCrunch what will give me. Wow. Wow, it's gonna be by quarters. I have to go through all this coding 0, 1, 2, 3, how many? No, okay. We are skipping it, or you can skip this. Let me see. Yeah, we are skipping this question number 15. I will remove this question number 15 and moving to number. Okay. Draw two normal curves that have the same mean but different standard deviation and describe the similarities and difference. Okay, I have prepared already. I have drawn same mean here. Let me see. Okay, let me draw same this way. I can do this way. And this will go and this way the mean is identical, right? It's go through the same center. Okay, here it's a little bit moved it, but it's the same mean, right? Let me go one more time. Straight line. Okay, so this is the same mean. Let's say mean is equal 10, for example. But deviation is different. Deviation is spread, see? The distance from the center to the element is this much. Here, the distance from center to the database or graph is this much. So, what similarity we have? That mean is the same, but spread is different, right? Okay, it's the same line of symmetry. The curve will be larger. The curve with larger standard deviation will be more spread out than the curve with smaller standard deviation. And that's it. I am done. Okie dokie.